Good afternoon, all. Uh, I hope everybody is in till now. Somewhere in the middle of the class, I'll be taking your attendance. Okay. Otherwise, Some of you say that you don't have internet, you have bad internet connections, attendance goes. Shall I take at the end or at the middle of the class your attendance? Please comment or speak. In the middle of the class, I should take the attendance at the end. Okay. At the end, your CR is telling at the end. Okay, good. At the end, I'll log the meeting in the middle, like of what is the time now? 15 to 20 minutes from the start of the class. I'll log the meeting. After that, whoever is there till the end, or at the end, I'll be taking the this thing attendance. Okay. Okay. Now, if we go to the problem, we were supposed to solve a problem. This problem. Hmm. Wait a minute. Give me. Write down the question till then. Well, oh, done. So, what does the question says? A pre-stressed concrete beam, 400. Am I audible? Hello. Am I audible? Okay. Okay. The question says what? A pre-stressed concrete beam, this much, 400 and 600 mm deep, has a span of 6 meters. This is your 6 meter. The beam is pre-stressed with the tendon bent as shown here. So now, like the principle we have already discussed in the first class of today. So this is your bent tendon, okay, provided in this particular beam of simply supported. So the external load on the beam consists of a concentrated load of, this is the concentrated point load acting here at the midspan, and if the effective pre-stressing force is 1200 kilonewton, that means this pre-stressing force is also given to you here. So that is 1200 kilonewton. Now calculate the extreme stresses for the mid span section. So we have to calculate here at the center, we have to calculate the stresses. Okay, so how to proceed? You have to calculate the stresses, right? So you know what are the stresses that will be developed in any kind of pre-stressed beams. How? You will have at the midspan your stresses due to this pre-stressing force P by A. Then another will be due to this is the dead load. Okay, dead load in the question is not mentioned, but here how we have got the dead load. If your dead load is not mentioned, dead load you already know, you have these dimensions are given to you. So from the dimensions you can find out the dead load of the beam. So that is comes to be 6 kilonewton per meter. Now this is the point load 180 kilonewton here. So what will happen, the stress will be P by A for the due to the pre-stressing force, and the stress due to the loads, that is the dead load, the 6 kilonewton, and the load due to moment which is going to come due to this 180 kilonewton. But since this is an eccentric tendon, sorry, not eccentric, this is a bent tendon. Since this is a bent tendon, and we know in bent tendon what happens, there is a upward pressure, upward thrust that will be given by your bent tendon to this 180 kilonewton. So what is that in a triangular profile, in this kind of triangular profile of bent tendon, what was your this thing, what was your upward thrust is 2p sine theta. So that is 2p sine theta. So you can calculate your upward pressure which will try to counterbalance this 180 kilonewton. So 2p sine theta we can also write it to be, we can also write this sine theta to be 10 theta, because your theta is very very small, so we can write it to be 10 theta too. And now once we know our we know 10 theta, we can find out this 2p 10 theta value. 10 theta is how much, if we consider this portion from here to till this triangular portion, this triangular portion, if we see, what we will get, 10 theta will be how much, 10 theta will be this divided by this. So this is how much, this, how you can calculate this, this is the, in this question it is given here, this is your tendon, and tendon is placed from the soffit at a distance of, from the soffit at a distance of how much, 160 mm. So this one you know, this is how much, 300, this is your 300. So 300 minus, if you do your 160, you will get your this distance, which is nothing but this distance, right? So this is your 10 theta you will get from here. 10 theta is equal to this divided by this. So now you will get your 2p 10 theta. So, and after you get your 2p 10 theta, you know what is your net load that will be acting, that will be 180 minus your 2p 10 theta. So after calculating, you got your 2p tan theta to be 112, as you can see in this figure, 112. So now what will be your load? Actually, the net load which is acting on your beam, that will be 180 minus 112. So the remaining load will be the load which will be acting here on your beam, and that due to that load we will have what? We will have a bending moment, and due to that bending moment there will be a stress due to that bending moment. So now if you see the calculations after that, you know everything is clear to you. You already know how to find out your stresses. P by A, P is already given to you, area you will know from the dimension. Then you have what? There is no eccentricity. Okay, so you will have the stress due to moment, and now moment is what? You have to calculate the moment due to this after compensation of the load. So if we go to the solution, you see here the tan theta is how much? If we consider the tendon at an angle theta with the horizontal, we have 140 by 3000, as I told you already here. This one, this is your 140. Because of this, 300 minus 160 will give you this to be this to be 140 mm. 140 mm. So this is 140 divided by your this, which is 6 meter. It was 36. That means 6000 mm. So this half is how much? Half is your 3000 mm. So in this way you will get your 10. Tan theta is how much? That 140 divided by your 3000 will give you your tan theta. And once you know your tan theta, you can calculate your 2p tan theta value, which is 112 kilonewton. We already have seen in the figure. Now the net load will be how much, which is actually being taken by the beam, that is that upward load 180. This 180 minus your this 180 minus your the upward load which you have calculated. How much is the upward load? 112. So now the load which is acting is this 68 kilonewton after counterbalancing, or trying to balance, after resisting the load of 112. This gets deducted from the total load of 180 kilonewton point load. So that will be your 68 kilonewton remaining now. So the bending moment due to this point load will be how much? WL by 4 we know, due to the point load. That is, now here actually now the point load which is acting is how much it was? 68 kilonewton. Okay, this is your 68 kilonewton. So that means now the point load which is acting here on your beam is 68 kilonewton. So the moment will be how much? Moment will be WL by 4, this one. So that gives our moment to be 102 kilonewton meter. And the dead load, we know, I told you the dimensions were given to you, unit weight of concrete, you know this much. So 6 kilonewton was your UDL, the dead load of the beam. Now due to this dead load, which is a UDL, you will have your moment WL square by 8. This is WL square by 8. Okay, so that gives your bending moment due to the dead load to be 27 kilonewton meter. So the total bending moment will be this this bending moment due to the vertical load, and the bending moment due to the dead load of the beam, which is the UDL. This two, after adding this total bending moment will be how much? Total bending moment now we have is 129 kilonewton meter. So after that we can proceed. Once we know that after counterbalancing the load which was acting now was 68 kilonewton point load, so we know the dead load, that is the UDL. Then we know the point load which is acting after counterbalancing of the uh, upward thrust due to the bent tendon. So after that we can calculate total moment. Once we know the total moment, we already know what is our stresses that will be developed. There is no eccentricity, so the stresses due to eccentricity is absent, but the stress due to pre-stressing force, stress due to the moment will be present. So that is nothing but your P by A plus minus M by Z. Okay, so P we know area, you know this one. Then we have your Z, we will know BD square by 6. Okay, so we know BD square by 6, we can easily calculate, and the moment also we have calculated just now, the total moment, this one. So easily we can find out now the total top stress and the bottom stress. This is the direct stress P by A, which you have calculated to be 5 plus 5 Newton per mm square, and the extreme stress due to bending moment is M by Z plus minus M by Z. You got it to be, after putting the values of moment and the section modulus, you have got your stress due to bending moment to be plus minus 5.4 Newton per mm square. That means this P by A is how much? Plus 5 plus minus 5.4 here. So the top fiber stress you will know. This is your top fiber stress, which is your, let me show you the stress diagram here now. Stress diagram, this is your section 400 and 600. Then we have what? This is the direct stress, which is 5 Newton per mm square, which is uniform throughout the beam. Then we have the stress due to bending moment plus minus M by Z plus the compression at the top and the tension at the bottom. So that was 5.4 Newton per mm square. So the total load comes out to be 5, the stress due to the pre-stressing force plus 5 plus our 5.4, which gives us the top fiber stress to be 10.4 Newton per mm square, and the bottom will be how much? 5 plus 5 Newton per mm square minus your 5.4. So that gives that, obviously that will come to be minus 0.4 Newton per mm square. So it is negative here. That means in this particular question with the bend tendon available here, what is happening at the top, you have the beam is under compression here at the top with a stress of 10.4 Newton per mm square, and at the bottom it has a small tension of tensile stress of 0.4 Newton per mm square. Okay, so this is your final stress diagram, and the values of the stresses acting are mentioned here in the figure of stress diagram. Okay, so this was your bend tendon, how you can how your bend tendon can resist some of the loads and then counterbalance and then give a leave over a small amount of load instead of 180 here in this case. So this was a simple bend tendon, how to solve. Another one, if you see another question here, if you take now this question, you can see here in this question your bend tendon is in this way, that is you're having an eccentricity here. This is your eccentricity, and your eccentricity is how much? Your eccentricity is 50 mm. Let me log thing here. Okay, so let me log in this. Let me take this. One, two, four.
Yes,
Hello.
ma'am.
No one present.
No present.
Four, four is present. Yeah.
Hello, ma'am.
Yeah, step. Okay, five.
Yes, ma'am, number 5.
Mm. Six. If someone misses you, this thing, okay, you can give your enrollment. If you miss out your roll number, you can give me in the chat also. Okay, 6, 7, 8.
Yes, miss.
Yes, 8. 9.
Present.
10.
10, ma'am.
Okay.
Please tell your enrollments. Okay, 10. Then 11.
Yes, ma'am. 10.
11. 11. 12.
Present, ma'am.
12.
Pure.
Okay,
Present, ma'am.
14. 12 present. 14
14 present, ma'am.
present. 15
15 present.
present. 17
Yes,
Subolem
ma'am.
Taiba present. 18 Zamir. 19
Yes, ma'am.
Moakum Imchem. 20 Kichu. 21 Anmar Samir.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
21
Yes, ma'am.
21, ma'am. Yes.
Okay, 21. 23
Dimitri
oh,
present, ma'am.
okay, Dhruba Kalita 24.
Present.
25 26 26 18. Okay, then we have 26 27 30 30 31 31 32 34 36 37.
Present, ma'am. 36.
Okay,
37 present.
37 38
Present, ma'am.
38.
Yes, ma'am.
Okay,
38.
39 39 42
42
43.
present, ma'am.
Okay, present. 43.
43 present, ma'am.
Okay, 44 45
Present, ma'am.
46 48 Vivek.
48 present, ma'am.
Okay,
48.
49 Kirit.
49 present, ma'am.
Then we have 50
Present, ma'am. 50.
51
51 present.
52 54
54 present, ma'am.
50. Okay, one thing I can do, you can note down till I take the attendance. You can note down the question, this question. Okay, note it down and also give your attendance. I'm checking your chats here also. 9 is present, 45 is present. Hmm. 42, oh sorry, 52 54
Yes, ma'am. 54.
4 55 56 57.
Yes, ma'am. Present. 57.
Okay, 58 59 60
60 present, ma'am.
61
60 present,
60.
ma'am.
Yeah, 60 is present. 61 63 Long Kumar. 99 101
Yes, ma'am.
99
101.
99 present.
Yes, ma'am.
Okay, 101
Yes, ma'am.
101 is present.
Present,
Please
ma'am.
tell
Present,
your
ma'am.
enrollments. Okay, 101.
101, ma'am.
Okay, 99 is absent. Okay, 104 106 108 109.
108 present, ma'am.
Okay, 109.
Ma'am, 99 present.
Okay, 99 present. 109 111.
Present, ma'am.
Okay, 100.
Present, ma'am.
Present. 113.
Present, ma'am. 113.
Present. 114.
Present, ma'am. 114.
Okay, 118. 120. 124.
120.
124 present. 133.
Ma'am, 133.
Okay. 134
134, ma'am.
present. 136
136. Present, ma'am.
present. 143
Yes,
144
ma'am. 143.
present. 144
143 present, ma'am.
yeah, 143 present. 144 145
145 present.
148 149 150 151 Chiranjeev Deka. Okay, I'll just call out who are marked absent. Okay, enrollment 2 absent, 7 absent. Huh? Please, okay, chat box you have written 151
151.
present. Yeah, okay, I have seen. Okay,
Present, ma'am.
okay. 2 is absent, 7 is absent, 10 is absent, 20 is absent, 25 is absent, 27 absent, 30, 31, 32, 34 absent, 39 absent, 46 absent, 52 absent, 55 absent, 56 absent, 58, 59 absent,
Ma'am, 34 present.
34. Okay, present. 149. Okay, so 57, okay, 52 is absent, 54, 55, 58, 59, 61, 63 absent, 104 absent, 106 absent, 109 absent. We have 118 absent, 120 absent. We have 144 absent, 148 absent, 150 is absent. Okay, anybody left out? No, no. Okay, then now see this question here. What is your question here? Here in this question you will see this is a little bit different from the previous one which we have done or solved. Why? Because you have an eccentricity here. You have an eccentricity here at the end section, and in your question you can see what is the question. It says that the beam carries a point load of itna itna that determine the stress distribution for the end section and the midsection. That means this time you have to calculate the stresses at this end section as well as on the midsection. Okay, on the end sections and on the midsection, your stresses. So what will be the stresses here in this case? In this case, see, you have the pre-stressing force P. So the stress due to pre-stressing force will be present. You all know this. Then you have the stress due to obviously loads are here, that is your point load is given to you here, and your dead load is, that is the UDL is also given to you here, 6 kilonewton per meter here, and the point load is 160 kilonewton given to you. So the loads are there obviously, so there will be a moment due to the loads present, so that means there will be obviously stress due to that moment. So two stresses have already come, but now in this case you will also have a stress due to eccentricity, because in this you have eccentricity. Okay, so you have eccentricity here at the end section, so there will be stress due to eccentricity. Now since this is a bent tendon, we know there will be an upward pressure here, and you know how to calculate it, 2p tan theta. If you see here, this is your calculation area, section modulus Z, Then we have, sine theta is how much? Sine theta is your how much? Sine theta is 150 by 3000. How? Because of this 150. This is your, okay, now you see here, tan theta is what? This perpendicular distance by your this length, half of the span, this portion, because we are taking this triangle. Since we are taking this triangle, this one, since I'll show you here, since you are taking this portion, this and this triangle you are taking, so now you know what is your this value. This value will be your, this is 100 mm plus this is your 50 mm, this portion, this is 50, so that means this is 50, this is 100, so 150, this total is 150. So 150 divided by your 3000 will give you your tan theta. Once you know your tan theta, you can find out what? Analysis of the end section. We know on the end section here, on the end section, since there is no this thing, we already know that in the end section there is moment is always zero due to the load, because load is acting here at the center. Okay, so the moment is always maximum here in a simply supported beam. Our maximum bending moment is always at the center, and at the end section it is zero. Yes or no? For a simply supported beam, you know that your bending moments here is zero. So what is your now if you see, now if you see here, what is your this thing? Now you can see here, and the end section, what are your stresses? P cos theta by A. Cos theta is negligible since theta is very, very small, so we can write it to be P by A. And we have P cos theta into E. That is due to this eccentricity here. At the end section, you have this eccentricity here, 50 mm. So due to this eccentricity, there will be a moment generated P into E. Right. So now you can see here there is a moment will be here. Earlier what used to happen is, due to eccentricity, when you had a tendon, in this way you had a beam, this is the center line, here you had your tendon, so you had an eccentricity here, and that time your moment was what? Minus plus, right? Due to eccentricity your moment was in this way, tension at the top, at the bottom compression. But here in this case you see your tendon, your eccentricity is above the CG, that is the centroidal axis, above the centroidal axis, and so your bending moment due to the eccentricity will be this. So that means plus at the top and minus at the bottom. So at the end section, if we see now, our meeting is going to end in, I'll just show you how to solve this. So and at the end section, you know what are the stresses now? Since moment is zero, so at the end section, we will not get any stress due to the moment, bending moment, but we'll get a stress due to this eccentric moment, PE by Z, which is plus minus. And why it is plus minus, I told you, because the moment is now in this way, our CG is above the centroidal axis. Simply by putting the values, now you can find out your top stress, because you have this extreme stresses at the end section is how much? P by A plus minus PE by Z, and at the top will be how much? You got your P by A to be 4.17, your PE by Z to be 2.08. Now the top stress, 4.17 plus 2.08, which will give you your top stress to be this much at the end section, and at the bottom section of the end section, you will get how much? 2.09. You can see the diagram here, which is your this one, 2.08 here, So final stresses at the end section is, that means the entire in the end section here, at the end section your beam is completely under compression, because you can see here this is our stress diagram for the end section, which is at the top 6.25 stress is there, and at the bottom we have here, at the bottom of the end section we have the stress is 2.09 Newton per mm square. Okay, so and then this thing is for the end section. For the mid section, like in the previous class we have done, at the mid section we have the downward load this much, 2p tan theta, you can calculate it. Then you will get the net downward point load you will get, which is the total the downward load 160 minus your upward force 100, so that means the remaining load is how much? Net load 60 kilonewton. So the moment due to the loading will be, point load will be this WL by 4, 60, remaining 60 is taken into consideration, so WL by 4. So the bending moment also you will get here. So the one more bending moment due to eccentricity you are going to get, which is your 1000 into 50 by 1000 here, because at the center also you have this eccentricity 1000. Okay, so bending moment due to eccentricity of the pre-stressing force is how much? 1000 P. This is your P. This is your E. Okay. Then your total moment is how much? 167, because this is the moment due to eccentricity. The moment due to point load is this much. Sorry, the dead load is this much, and your moment, another moment was this one, 90 kilonewton. Total moment we got to be now, moment due to this eccentricity 50. So the total bending moment is this much. Once you know your bending moment, you can easily calculate now these stresses. Okay, so the stress at the top is plus 11.13 Newton per mm square, and at the bottom is minus 2.79 Newton per mm square, which is here your stress at the midspan section. Here at the top it is stress 11.13 Newton per mm square, and at the bottom this beam is under tension. That means at the center your beam is now under compression here, and at the bottom you have a tensile stress here developed. Okay. Okay, so this was your stress with eccentricity. When you have this kind of eccentric tendons here, this kind of eccentric tendons, you will have at the end section stress due to bending moment, and stress due to eccentric moment, and here you will have all the three. That is all the three means the due to load and eccentricity, the moments which are going to act here at the midspan will be calculated in this way. That is the total moment you have to calculate, the total moment due to this point load, moment due to the life load here, life load due to this life load, and this dead load. There will be moment and the moment due to eccentricity of 50 mm.